Hi everyone, let's discuss about Rabin Karp string matching algorithm. What is Rabin Karp's algorithm? It is an algorithm used for searching or matching patterns in the text using a hash function. Unlike the naive string matching algorithm, it does not travel through every character in the initial phase. Rather, it filters the characters that do not match and then performs the comparison. Simply, it is a string searching algorithm that uses hashing to find the pattern in the text. So how does this algorithm work? The algorithm works by first calculating a hash function, hash value for the pattern, and then comparing the hash value to the hash values of all the substrings of the given text. If the hash value matches, then the algorithm compares the pattern of the substring to see if they are a match. Let's take a look at an example. There is text and pattern as given. We need to find if this pattern exists in the text or not. So instead of comparing each and every alphabet, we take a single value of the pattern. These alphabetical values can be written as numbers, which we already know as ASCII values. The lowercase a has 97, b 98, and so on. As of now, since they are larger and are heavy for calculating, let us assume them to be 1, 2, 3, and so on. So for the pattern to be a single value, let us consider the hash function to be the sum of these alphabets. So the hash value of the sum is 7, which is also known as hash code, and the hash function is also denoted by h of p. And the length of the text is stored in a variable called as m, which is 8, and length of the pattern, which is stored in n, is 3. Since the length of the pattern is n, we take 3 characters of alphabets as one substring and compare it to the pattern. So the first comparison is A, B, C, and after calculating the hash function, the result is 6, which does not match with the hash value of the pattern. So we move on to the next one, BCB. This BCB, after calculating the hash function, gives us the same result as the hash value of the pattern, which is 7. So now let's compare every alphabet of the substring to the pattern. As you can see, this definitely does not match. So we move on to the next one, CBB. This hash value is also the same as the hash value of the pattern. So we compare every alphabet of the substring to the pattern. This does not match. So we move on to the next one, BBC. The hash values are same and the alphabets are same. So this is definitely a match. Even though we have found the match, the iterative process ensures that no occurrence is missed, even if it has found the same pattern multiple times. So we move on to the next one, BCA. The hash value does not match, so next one, CAA. The hash value does not match. As you can see here, we have taken such a simple hash function which results in the same hash value repetitively. So if you take such a simple hash value, then there is a possibility of collision with the other pattern and other substrings which are having the same code, though they are not the pattern. So this is a drawback. The drawback here is that there are many codes and hash values which are same but are not the same with the pattern. This is called as spurious hit. A spurious hit occurs when the hash value of the pattern matches with the hash value of a window of the text but not the actual pattern. As we have seen before, the value of BCB and CBB is the same as the value of BBC, which is 7, but the pattern does not match. This is a spurious hit. In such a situation, the maximum time taken by this algorithm may be big of m into n, and spurious hit also increases the time complexity of the algorithm. This results in the worst time complexity. So, to avoid this, we use rolling hash function. What is a rolling hash function? It is a hash function that is used to efficiently compute a hash value for a sliding window of data. So here we can choose any prime number. As of now, we have chosen 13 and have to be chosen in such a way that we need to perform all the calculations with single precision arithmetic. So and the modulus is also used to minimize the spurious hits. Now let's calculate the rolling hash function of the pattern. As we have assumed the values of the uh, alphabetic as 1, 2, 3, 4, we use the same values to calculate the rolling hash function, which is 2 into 100 plus 2 into 10 and 3 into 1 mod 13. We have taken and considered the power of 10, which results in 2. This is the rolling hash function of the pattern, and we use this to compare the substrings of the text. Now let's start comparing. The first one is ABC. After calculating the rolling hash function of this, we found it that the pattern and the hash value of the substring do not match. So we move on to the next one, which is BCB. Now this also differs. As we have seen before, the hash value of the pattern and the BCB substring was same, but in this case it is not same. This is a difference. We move on to the next one, CBB. This also is different from the previous value, where the pattern is 2 and the rolling hash value of CBB is 10. So we move on to the next one, BBC. This BBC substring and the pattern have exact same value. That means this is a match. This is a perfect match. So we move on to the next one. DCA, not a match. CA, not a match. So as we can see from this, the rolling hash function, which includes a prime and modulus, gives us more efficient and accurate values than the sum, which is a simple hash function. This is Rabin Karp's algorithm. The execution and the output looks like this. And the best and average time complexities are big O of m plus n. And the worst case is big O of m into n, which is due to spurious hit. And the space complexity is big O of 1. This is because the algorithm only needs to store a constant number of variables, which are hash value and length. So we can conclude that the rolling hash function method eventually reduces the time and is more efficient, and also reduces spurious hit, which decreases our time complexity. Thank you.